Alright, we're going to take a quick review on logarithms. So as usual, leave one line this time, not two, but you're going to do 2 pages because it's going to be quite a little bit of review. Alright, so logs. So there are 2 pages on the same tab because I don't want to run out of space in case I need some more. Alright, so intro to logs. In its simplest form, a logarithm answers the question, how many of one number do we multiply to get another? How many of one number do we multiply to get another number? So for example, how many 2's do we multiply to get 8? How many 2's do we multiply to get 8? Well, we know that 2 times 2 is 4, times another 2 is 8. So we needed to multiply 3 of the 2's to get 8. Therefore, the logarithm is 3. So again, how many of one number do you multiply to get another number? That's what a logarithm is. Alright, so we can write it this way. Log of the base 2 of 8 is equal to 3. And that means exactly 2 times 2 times 2 is 8. Where the number of 2's is the logarithm. Right, so that base of 2, the number we're multiplying by itself, is called the base. This is a listening check. This is a listening check. Color in the word number. Color in the word number. Log of the base 2 of 8 is 3 is how it's read. Log of the base 2 of 8 is equal to 3. Alright, so let's convert some things. So 2 to the power of 3 is equal to 8. If you want to write that into logs, it's really simple. You start at the 2, you go counterclockwise, past the equal sign, and then back to the last number. So like writing log the base 2 of 8 to the power of 3. Let's go backwards. Let's say you're given log the base 2 of 8 equals 3, and you have to write that in exponent form. So again, the same thing. You start with the first number, go past the equal sign, then over back to the other number. So 2 to the power of 3 is equal to 8. Let's take a look at another example. Let's say we have natural log of 2 is roughly 0.693. That ln is natural log with a base of e, and it's what we use in the calculator. You'll see what we're doing with that a little bit later. Alright, so again, it has a base of e, so let's go ahead and just write the base of e. And then you start from that. First the base, go past the equal sign, and then back over. So this is e to the 0.693 is roughly equal to 2. Let's take a look at another example. Let's say we had log. Now if you see it written just log like that without a base, it's automatically the base of 10. And again, this one is also in the calculator that we're going to use a little bit later on as well. Log to the base of 10 if there's nothing written there. So again, put it in so you can see, and then you start at the base, you go past the equal sign, and then back over. So this 10 to the power of 3 is equal to 1000. And that's pretty much it. That's how you convert back and forth between exponential functions and logs. So let's take a look at if you were asked to evaluate something. So let's say you had log the base of 9 is equal to x. So again, you go past the equal sign and back over. So this is 9 to the power of x is equal to 9. Well, 9 to the power of what is equal to 9? It has to be 1. 9 to the power of 1 is 9. Now, note this. If it has the same base and the number right after the base, then it is always equal to 1. So if those two numbers are the same, it's always going to be equal to 1. You don't have to actually convert it.
Man, this is that Christ all of my speech, dude. Can't leave a message, strike off for that evil. Gotta give him what is right.
Log to the base 2 of 2 is equal to 1 because they're the same number. A natural log has a natural log as a basis e of e is also equal to 1. If you had log to the base 10 of 10, that's also equal to 1. Remember, if you don't write the base in, it's automatically 10. Alright, so again, it's always equal to 1. This is a listening check. Put a circle around number 9. Put a circle around number 9. So we had this again, start at the base, go over and back over. So 3 to the power of 5 is equal to x. Well, 3 to the power of 5 is what? 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. And then 81 times 3, because that'll be my fifth one, is 243. So 3 to the 5 is 243. And let's take a look at one more example. Let's say you had y equals log to the base 4 of 1/4. So we're going to rewrite this because log has to be first in order for our little thing to work. We'll pass the equal sign, then back over. So 4 to the power of y is equal to 1/4. Well, how am I going to make 4 a fraction? That means y has to be -1, because anything raised to the power of -1 is going to be a fraction. Alright, change of base formula. You just need to memorize this. It's not hard at all. It's log of the number over log of the base of whatever you want. So let's take a look at an example. So if you had this, it would be log of 39, the number itself, over, and this is to the base 10 by the way, over log of 4. The reason we do this is so that we can put it in the calculator, because there is no log to the base 4 in the calculator. So we're going to use log, that's again naturally base 10, 39 divided by log 4, and we can evaluate it in the calculator to roughly 2.64. Let's take a look at another example. Let's say we had log to the base 3 of 42. So we can rewrite it by changing the base so we can put it in the calculator. This would be the log of base 10 of 42 over log base 10 of 3. And then we can just punch out in the calculator because there's that button that we can use with the base 10, and we can get that. Let's take a look at one more. Log to the base 32 of 5. That's log of 5 over log of 32, and again we can punch that right into the calculator and get 0.46. Alright, the last thing we're going to look at is the properties of logs. Okay, just like exponents, these properties come from exponents, and what they say is if you have log to the same base of something multiplied together, you can separate them and add them. So you can say log of that same base of m plus log of that same base of n. If you had something the same base and it's divided, you can separate them by subtraction. If you had something of the same base of 1 over n, or the reciprocal, then it's just negative that base to just the n. And finally, if you had a power function log of a to m to the r, you could just bring the r down and there would be r log of a to the m. Okay, so we're going to actually go over a few examples so that you can see how we're going to use these. Pretty much just want to review everything we've done on this page. Alright, so let's look at number 1. Given a equals c squared over 4 pi, show that the natural log of a is equal to 2 natural log of c minus natural log of 4 minus natural log of pi. This is a listening check. Color in 1. Color in 1. So we're proving this basically. Alright, so we're just going to use the properties of logs that we just learned. So we start by taking logs of both sides. So log of a equals log of the right hand side. Then now we can separate all this using the properties. So we're going to use the power, the division property, multiplication property. So we can bring the power down, so that's 2 log c minus, and I'm going to put this in parentheses because I'm going to separate the 4 times pi. And remember, multiplication is addition. Alright, so now I'm going to simplify that to log c minus, go ahead and get in the house, so negative log 4 negative log pi. And that's it. Let's take a look at a more difficult one. So that this is equal to this. This is a listening check. Color in given. Color in given after number 2. So again, you start by taking natural logs of both sides. So log of r equals log of this whole thing. And I'm just going to rewrite this whole thing because the cube root of something is like saying that same thing to the power of 1/3. It's the same thing. Alright, now I'm going to bring the power down. Or I'm going to use the properties and use the power, the multiplication, the division one. So I'm going to put the power down, so 1/3 of log of 3v over 4 pi. Then I'm going to separate the 3v and the 4 pi. Because it's division, it's going to become subtraction. So it's log of 3v minus log of 4 pi. Alright, now I'm going to separate each thing. So log of r equals 1/3. Log of 3v, that's multiplication, so it's going to become addition. So log of 3 plus that minus, I'm going to put this in parentheses because when I separate it, it will change the last thing. Because multiplication becomes addition. Now let's go ahead and simplify this a little bit more. So we've got 1/3 of log of 3 plus log of v, and then let's get in the house, minus log of 4 minus log of pi. And I'm just going to check my answer to make sure it matches, and it does. So that's pretty much it, how you use properties. Alright, so just to review, write 3 squared equals 9 in log form. So again, you start at the first number, you go over the equal sign, and then back over. So it's log to the base of 3 of 9 is equal to 2. Alright, what if you were asked to solve this? Draw my river, and automatically I can see I can go ahead and just divide both sides by 2. Which leaves me log to the base 3 of x equals 5 over 2. Then again, start at the first number, go past the equal sign, and then back around. So that's going to be 3 to the power 5 over 2 is equal to x. And then I'm just going to write what that is. That means 5 3's all square rooted. Well, square rooted means that you can take out pairs of 2 outside. So you're going to have 3 3's outside, which is going to give you 9, leaving the square root of 3 inside. If you don't know how to do that, you need to look at simplifying radicals. Just ask me and I'll direct you. Alright, let's take a look at another example. Now, there's several ways you could do this. You could value it 8 cubed, but I'm not going to. I don't feel like dealing with big numbers. So I'm just going to use the power rule to bring it down to the left. This is what I have. Then divide by 3. Then I'm left with log to the base a of 8 is equal to 10 over 3. And then again, starting the first number, going past the equals and back around, a to the 10 over 3 equals 8. Now, in order to show you my next step, I'm going to show it to you with numbers. Let's assume we have 3 squared equals 9. Well, 3 squared is like saying 3 to the power of 2 over 1 equals 9. If I wanted to transfer that to the exponent to the 9, all I have to do is flip it. So it's going to be 1/2. So 9 to the 1/2 is the same as saying the square root of 9, which is equal to 3. So all I have to do transfer it to the 8 is flip it. So it's going to be 3 over 10. 8 to the 3 over 10. We're going to put that in the calculator. So you put 8 to the power is that little thing right there, and then parentheses 3 over 10. So that's going to give me 1.8, roughly 1.7. And let's take a look at one more question. So let's say we had to solve this. First thing you do, bring the power down. So 4z minus 3. Oh, take the natural logs of both sides. So you took natural logs of both sides, then brought the power down. Alright, let's divide by log of 9. So I can try and get the variable by itself. So 4z minus 3 is equal to log of 100 over log of 9. We want to add 3 to both sides now. So 4z is equal to log of 100 over log of 9 plus 3. Then my final step is just to divide that by 4. Z is roughly equal to, put it in the calculator. Now you have to be careful to use parentheses. So we wanted to do the whole top first, then divide it by 4. So I'm going to open 2 parentheses, put log of 100 over log of 9, close the parentheses. I'm telling the calculator to do that bit first. Then once it's done doing that bit, I want it to add 3, then close the parentheses so it can do that first, and then divide it by 4. And you're going to get that. Now, I could have done this individually, so I'm just going to show you real quick. I could just keep pressing equals on each one, but you need to get used to putting it all together. Plus 3 equals, divide by 4 equals, and you see you get the same thing. Alright, so that's it. That's pretty much the fastest review I can do on logs. So let's practice.